All right, so I'm doing a separate video for the calculator part of this polynomial inequalities worksheet because I wanted to use Desmos this time instead of the graphing calculator. So just as a reminder, we have a position function, and for these different problems, we're going to be given different initial velocities and different initial positions to start with. So use this function. A projectile is fired straight up from ground level. So the level at which it's fired from is S sub 0. In this case, that's 0 feet above the ground, with an initial velocity of 112 feet per second. That's V sub 0. During which times will the height of the projectile exceed 96 feet? So let's just set up our function first. So we want to know S of t is equal to negative 16t squared, that's built into the formula, plus 112t plus 0. And we want to know when does that exceed or go over 96 feet. So I want to know when is S of t greater than 96. So there are a few ways we can do this in Desmos. Depending on how nicely the problem works out, you could just type in negative 16. You might have to do x squared. But I want to solve when is negative 16t squared plus 112t greater than 96. So I could try doing this inequality to start. Like I said, though, I don't think that it likes t if you don't have an s of t to go with it. So if I'm just typing in this inequality, let's type in x. Keep typing t greater than 96. Let's just see if it solves it for us. So yeah, so anytime between 1 and 6, those are nice numbers. So Desmos gives me that. Sometimes when they're irrational numbers with decimals that go on forever, sometimes it doesn't show that for me. So yeah, so I can solve this right now. This will be greater than 96 for any t between 1 and 6. And I'm not going to include those endpoints because, and you can use either interval notation or not, but I'm not including the endpoints because this just says greater than 96, not greater than or equal to. Another option is to subtract 96, call this S, or maybe just f of x since I have x's. Another option is to subtract 96 and look at when is it greater than 0. You get the same answers. Okay. Problem number 16. A projectile is fired straight upward with an initial velocity of 128 feet per second. So new v sub 0. From the top of a building 50 feet tall, new S sub 0, during which time or times will the height of the projectile be under 200 feet? So S of t is equal to negative 16t squared plus 128t plus 50. We want to know when is S of t less than 200. All right. So again, let's just try this equation with x's. When is that less than 200? Okay, so this does give me nice answers here, but I do have one other thing to consider. Can my answers go to negative infinity and positive infinity? Does that make sense? So remember, t represents the time that this projectile is in the air. So time can't be negative. So first off, I'm going to say including 0, t can be less than or equal to 0, 0 can be less than or equal to t, and let's see, under 200. We're not including the time where it hits 200. So less than 6.574, round to 3 places. And then there's also this other time where, oh, sorry, I got my numbers mixed up. Careful with the labels where they show up. 1.426. The other time is 6.574 is less than t. But can this go on forever? I assume when the projectile hits the ground, we're stopping our clock. So how do I figure out when the projectile hits the ground? That's not too bad. Remember, this is the S of t equation. So I'm just going to call that S of x. All you're really doing there is, so here's the S of x equation. So here is where the projectile hits the ground. So we do need to stop our time. Let's stop our time at 8.373. And I am including the stopping time and the starting time because at both of those times, the projectile is either at 50 feet or at 0 feet. It's on the ground, and both of those are less than 200. So both of these are solutions. So you have lots of options for how to solve when you have Desmos, which is kind of nice. A rectangular playing field with a perimeter of 100 meters needs to have an area of at least 500 square meters. Within what bounds must the length of the rectangle lie? So let's start with perimeter of our rectangle. I'm just going to call this x, this y. So we know perimeter of a rectangle is 2x plus 2y, and that's equal to 100. Let's divide everything by 2, just to work with smaller numbers. And we're talking about area, which is normally x times y, but we don't want to have two variables here. So let's make this a function of x, meaning solve your perimeter equation for y. And now I can say a of x equals x times 50 minus x. Within what bounds must the length of the rectangle lie to be an area of at least 500 square meters? So we want a of x to be greater than or equal to 500. All right, so let's go back to Desmos and start again. So a of x, actually, again, let's just see if it works out nicely. 50 minus x, when is that greater than or equal to 500? Okay, here and here. It looks like anytime x is between these two numbers, it says within what bounds. So let's round to 3 places. And you do not need to overthink the rounding. We're just rounding to 3 places. So x can be, let's see, within what bounds must the length of the rectangle? We're calling x the length. So we're just going to say between 13.820 less than or equal to, since this is equal to, x, which is less than or equal to 36.180. Okay, and our final problem here. The revenue and cost equations for a product are R of x equals this. So here's revenue. Revenue is the amount of money you're making, money made, like how much it's coming in for. Cost is how much it costs, so money lost. C of x is this, where R and C are measured in dollars and x represents the number of units sold. How many units must be sold to obtain a profit? Profit is the amount of money you're taking in minus the amount of money that you lost from making the thing. So revenue minus cost. We want profit of at least 1,650,000. So P of x should be equal to R of x minus C of x. And we want P of x to be at least 1,650,000. So you can either type this in all at once, or anytime there's subtraction, I feel like sometimes we mess up on, you need to make sure that you distribute the negative through the cost equation. So either use parentheses, or you can do this, R of x equals x 50 minus 0.0002x. You can write them in separate lines. What was cost? Cost was 12x plus 150,000. Oh, it probably doesn't like my comma. Okay, don't put commas in. And then P of x is equal to R of x minus C of x. Now, the way that my window is zoomed in, I can really only see R of x right now. The only one I care about is P of X. I want to know when is, I don't know if this is going to work. When is P of X greater than or equal to 1650000? Does it find an answer for me? I'm going to have to zoom pretty far out. We're talking about making products and we want a lot of them. Oh, there it is. You can also turn off the ones that you don't want. It will still graph these. Let's see. It looks like if we were between 90,000 and 100,000, we should get that profit. Okay, so how many products must be made? Anywhere between 90,000, and I'm including these because we hit that profit exactly, and 100,000 units. So inequalities can be solved pretty easily in Desmos. And for any of these, if this inequality part isn't working for you, you could always graph P of X and graph the line y equals 1,650. Remember, we've done this before for like solving equations. And you have to play a bit with the zooming. But you get the same answers if you find these points of intersection. So when is profit, the profit curve is above the line that we want for those same two values. So there are a lot of ways you can use Desmos to solve, but if it will do the inequality for you, that's even better.